Okay, so we're going to start with nutrient cycles. Let me go ahead and get us to the beginning of your discovery education here and just kind of see where we're at. We're still in Unit 2. We've gone through energy for life, and we've looked at photosynthesis and cellular respiration. This is where we hit the pause button and we take a look at some Earth and space science related. We're going to start with nutrient cycles, and as you can see, then we'll move on to weathering specifically, and we'll look at erosion and deposition as well. So let's go ahead and click on nutrient cycles. This will be 2.4. And why don't you go ahead and draw your Cornell notes, and let's make a point to reference this as well. Okay, discovery, education, living Earth, 2.4.1. Okay, we're going to be looking at explore number 1 today. Okay, so we'll click on that. And there you go. So we're going to take that green question there. What are the processes and features of the water cycle? Go ahead and hit pause and tell me what you know. Okay, hopefully it took a moment to do that. We're going to track along with the text there. The water cycle, Roman numeral 1, also known as the hydro, meaning water, hydrologic cycle. 97% of all the water on Earth is stored in the oceans as salt water. I think most of you have heard that fact at one time or another, right? And of course, we know that over 3/4 of Earth's surface is covered by water. Okay, so how do you and we rely on fresh water? In fact, many organisms require fresh water. How do we get that? The water cycle. The water cycle plays a very big role in cycling water, evaporating water from the salty oceans so that you have fresh water that enters into the air. And from the air, it can condensate and then it can return back to Earth's surface where it can collect on the surface or underneath the surfaces as fresh water. Okay, so that's kind of it in a nutshell. Um, there's 3 primary processes. You just heard me talk about those. There's evaporation, condensation, and precipitation. Evaporation is where liquids turn to gas. You need heat to do that, right? The sun is the primary agent for heating up Earth's surface and causing water to evaporate. What happens when water exits a leaf? Because Earth is covered by a lot of green vegetation. You go into the jungles, it's very humid. Well, all that evaporation that's coming out of their leaves is called transpiration, sometimes called evapotranspiration. And obviously, we said when you're in those jungles or you're back in the East Coast, like Florida, it's very humid. Part of that is because of the amount of moisture in the air, either because water is evaporating from the surface or it's evaporating from the plants. And the amount that your air can hold in moisture is really dependent on temperature. If you've noticed, on hot days where it's humid, it's very sticky, it's very moist because warm air can hold a lot of moisture. You may have also noticed that it tends to rain on cold days, and um, because cold air can't hold as much water as warm air can. Okay. When we see water change from its gas form into a liquid form, that's what we call condensation. Okay, and in fact, when you take a look at clouds, those clouds are really just large collections of tiny water droplets that have condensed out of the air. Now, they don't always stay in the air, they will fall. We call that precipitation. Those water droplets become too heavy, the air becomes too cool, and so the water falls down as rain, snow, hail, or sleet. Okay. So, what happens when this water hits Earth's surface? Well, it can collect on the surface. Think lakes, ponds, rivers, streams, right? Seasonal lakes, that kind of stuff. It can also seep into under the ground. It can collect in what we call our aquifers. This is the stuff that if you ever drill a well, you're drilling into the aquifer to pull up some groundwater. So understand the difference between surface water and groundwater. So fresh water, not a lot of it, obviously. If we said 97% of Earth's water is salt water, that leaves us with only 3% that's fresh. And a big part of that is actually in the form of ice. It's frozen. Okay, big ice sheets on the ocean, large glaciers. Kind of depends on where you are. The closer you are to the poles, north and south, you just get a lot of ice. As you start to move a little bit south of the North Pole, or a little north of the South Pole, basically you're starting to move towards warmer latitudes. You start to see that these ice sheets can move. We call them glaciers, right? How much ice is on Earth's surface at any given time depends on the period of Earth's history. We've gone through ice ages where the global temperatures are very cold, and we see a good amount of the fresh water is frozen. And then we, like right now, are experiencing climate change. Global temperatures are increasing, and we're seeing a lot of the ice melt, right? So this stuff is cycling continuously. I think the last important thing to really realize, and this is going to set us up for the next chapters, this cycling of water really has an effect on the way our planet looks. The fact that tall mountains become short mountains through weathering and erosion, canyonlands and valleys cut into Earth's surface, again, from weathering and erosion. The movement of dirt and sediment from the higher mountain areas down into the valley areas where we farm. Because the ground is rich with nutrients, Earth is constantly changing its appearances due to those, due in part to this cycling of water. Okay, so the cycling of water has a lot of effects on our planet. Well, I hope that that was helpful. Go ahead and write your summary paragraph, and we'll talk to you guys soon. We're just going to make sure that you were able to see all of our text, make sure there is nothing that was missed. And it's looking pretty good. Yeah, looks like you got it all. All right, we'll talk to you soon. Bye bye.